Oh, Arthur, I want to tell you that back in 2017, I did a presentation on why the Earth is flat, and I'll send that to you. It's in the minutes of the Fort Worth meeting there. I think you'll find it quite entertaining. So I've also done presentations at the back in terms of where's my well, and in this particular case, I've really said we should have this go as where's my survey program, because without a survey program, I don't know where my well is. Next slide is bio. I've done a lot in different places, everything from operations to science to stuff in a few different companies, fields, wireline, MWD, manufacturing. So moving on. This presentation came out primarily out of work we did for developing a new model for the online course in wellbore positioning. This is an introduction to wellbore positioning. It's not designed to make you entire experts, despite how Daniel's presentation looked like. We gave him some of the foundations there, but he did the rest. The 3 short videos in that module were, first of all, understanding error models, secondly, using error models, and thirdly, survey programs. And the first 2 mostly came out of some webinar stuff that Andy did to reconfigure to where we're going. The first thing we did in this was look at why uncertainty models are so important. Touch screen there. Oh, right. What screen am I on here?
It's on your
Are we on left or right? Or?
Yeah.
Okay, thank you. Good. That's good. So first of all, we looked at technology, clarifying technology and things, why it's important. And the terminology I wanted to make clear in terms of, we talk about error model, we talk about framework, we talk about tool codes, positional uncertainty models, we talk about IPMs, and they all sometimes get intermixed and not quite sure exactly what we're talking about. ISCWS error model is not a tool code. IPM is not a tool code or a error model. So that's in the stuff. The first one we looked at was how the error model is built up for MWD surveys, its constituent parts, how that is extended for use with other surveys, including gyros, and how they produce ellipsoids of uncertainty. And then in the second video unit, we looked at how the models are intended to be used, which probably appeals very much to Mark's heart. And I'm going to go back over there to put that down. I've got you all screwed up here. I've got it. I'll okay. Right, okay. So the third video was on survey programs, and that's what I found that current good examples are hard to find. So several of these slides are adapted very poorly from the survey program video in the unit. The reason I wanted to talk today was because we do so much good work in the anti-collision groups, error model subgroups, everybody else, but without knowing how that's being applied, our work is wasted. So the survey program is designed to fix that. So we talk about what a survey program is, what they are, when they're used, and what to watch for. So first of all, the first term I came up with in addition to this other stuff was ADSP, or Actual Design Survey Program, and that may be specific to one operator. But it's a survey or sequence of surveys to defining the definitive well path for the as-drilled actual well. Okay, that's kind of key. Why do we do it? The purpose is to ensure that sufficient attention is paid to the actual surveying the well to meet the primary positional uncertainty goals of that well. And it's very important to note those goals can apply to different parts of the entire well's lifetime, before, during, and after drilling. For example, ensuring safety while drilling, like avoiding other wells or geohazards, actively positioning the well to hit the target, and then placement of completions equipment, production analysis, future plug and abandon operations, recompletions, or well drilling features in that area, so you know how to miss that one in the future. So it's important that the plan is to meet those goals is clear, communicated to everybody involved, and properly implemented. And that's where the survey program comes in. So planning phase, drilling phase, entire life. Development, implementation, recording, understanding, everything that's going on. So what actually is a survey program? So for this, I went to the upcoming API RP78 recommended practices for wellbore surveying and positioning, as you all know. And here's how this defines the survey program. I'm not going to go into all the details here because it's really an introductory thing anyway, but specifically I've highlighted a few different bits here. Specifically, it is part of the overall well design and includes instructions for all stages of the operation. And I include, when 78 is released, I'll include an extract from that too. I've highlighted a few of the words. The survey program shall be part of the drilling program, not an option. It will define the positioning requirements. It will be detailed enough for proper execution. It'll be fit for purpose to meet the well's positioning objectives. That doesn't mean to say it's got every tool and bell and the whistle in place, but it does mean you've got to have adequate tools to meet what you're trying to do with that particular well. It's all designed to ensure proper application of the chosen tools and models. So this is what it includes. Survey tool type, the survey interval for that tool type, the start and end depth, positional uncertainty model assignment, and north reference. Important thing there is specifying the specific tools being used and making sure they're used at the correct time to meet the objectives. So you've got things like the tools. The tools are not necessarily just the hardware, but they can be the hardware and the software tools such as the correction software. So that's where things like IPMs, position uncertainty models, combine more than just hardware effects. It tells you where that should be applied. It tells you when it should be applied. It tells you which tool code you should be using. And I would expect that you would know that basically you have to have a north reference and a datum, etc., to go with that. So here's the example of a very simple survey program. Where they drilled the well blind to 1,200 feet. And after the 20-inch casing, oh, I'm going to that one, the next one. Basically, what they've done here is they've drilled the well 1,200 feet, blind, and then they've gone back in and surveyed in part two, do it again with MWD applying sag corrections all the way from surface to TD of this well at once per stand. So there's a simple tree diagram or a diagram of that well. The tree diagram is a very useful way of visualizing the effects that survey tools have. So in this particular case, what we have is we have the first part one was drilled blind. So you have an uncertainty that's quite wide. They've obviously identified that uncertainty, if it was continued down to the TD, would be inadequate to meet their concerns and goals for further down. So they've been resurveying the surface all the way down to make sure their goals are met. And that's it again, just to follow through what that's going there. And these are just some examples. This is a more complicated example. I don't have a tree diagram for this one. You can see it's surveyed in parts. The first part's drilled blind. They go in with MWD. The second part, they'll then go back and drill through their extra tools, pardon me. Third stage, they'll go back and drill from the surface, survey again from the surface to that casing shoe, that 24-inch 18.5/8 casing shoe using gyro. So you've now got a tighter ellipse of uncertainty at that point in time. And moving forward, it's giving you depth, it's giving you time, it's giving you the order. So this has been surveyed in 3 parts. The important of the parts is you can't use the error models from part 2 or 3 when you're drilling part 1. You cannot apply that gyro before you've actually run it, which is a concern we have sometimes in the industry. A more real program here, as implemented by a major operator. They plan to survey in 3 parts. Additional surveys while tripping out the casing points. The survey tools have been specified, a mixture of gyro, MWD, EMS, The tool codes are all applied from the OWSG tool groups, except for specific gyro vendor groups. So it also specifies the survey frequency and the QC requirements to ensure those tools are run properly and the goals are met. So it's a nice format, tabulated format of this. So where do you find it? The first place to start is often with Well Planner. And this example here on the left is a survey from the Survey Program tab of the Compass Software Actual Design Properties section. Some operators will have parts of this in their fuel drilling program documents. Others, separate instructions will be given to different contractors for pre-drill, vertical, curve section. And the final example here is what you might expect from a good survey management company. And this includes CRS type things, it includes the different references you need and where it's going to be done. It's got a geomagnetic in the bottom, so it's no doubt really about what you're looking to do. So that's, I'm not going into the full details of the survey program, but can you give me the survey program for the well you're working on right now? You can. Good. So that's a great thing to do. A lot of people can't, and that's, I mean, the people I asked really struggled to find a survey program. They find bits of it here and there because you need it before the well to figure out what your plans are, where you're planning your uncertainty, and are you going to meet the goals of the well, whether it's safety or the target sizes. And when you're drilling, it might be modified, but the operators need to know what tools they should be running. Are they appropriate at the right time? And afterwards, we're trying to figure out where the well was, so we have a good record of it. So the reason I wanted to stand up here and bitch a little bit is because I think this is the pinnacle, eventually, of what we do, all the work we do. And I don't think it's being properly applied. I think we all agree it's not being properly applied. There has to be QA, QC. You know, the work that Mark's been doing with the error model in terms of the rotating model. Again, he was going, but you know, we're just putting this mathematical framework together or this tool together that this is what it applies to. But this is the document that tells the people in the field what they should be doing to make sure that's applicable and that the people auditing and go back in the past can say, yes, that was done properly. So there may be a hole in what we're doing. Maybe the OWSG group, if they're active, should maybe be taking this on and pushing it through. But maybe the software providers can go and say, we can pull this information out of our software and present it in one place. I'm just asking that question. So that's the end of the question of why there was a question into my